FluoRender is a tool that was developed for confocal microscopy data, and it's focused on giving biologists an easy-to-use method for both doing visualization and analysis of 3D confocal microscopy data.
So basically, you load a volumetric data or a group of volumetric data as channels into FluoRender, and you could look at them and interact with them. Basically, you do rotations and zooming in and panning. You could paint on a data set just like using a paintbrush in Photoshop. And you could select things using the paintbrush. And the selected part can be extracted and analyzed to calculate their size and intensity, etc. And you could also draw rulers on the data and do some measurement.
It started out with a collaboration with the late Qibin Chen, who's a neurobiologist that was studying zebrafish, and he was using commercial tools like Amaris and Velocity, and found those tools were lacking in his ability to visualize and do analysis on his data. So he came to talk to us about could we help him, and at the same time we had a lot of work on volume rendering and multidimensional transfer functions, and said, you know, this could apply to the confocal data, though we'd never had done it. And through that collaboration, we built the prototype tool that turned into FluoRender.
The collaboration in the beginning of the project was limited to me and Hidel. So basically, Hidel was the only end user in the beginning of the project. But later, as we had more users of this tool, Hidel was more or less acting as a bridge between other end users and me as a developer.
I visited more than 60 laboratories in UK or US and Japan. And I did a demo for all the laboratories. And also I gave the talk, where we incorporate most of our feedback from these 60 laboratories.
FluoRender was initially designed for neurobiologists studying zebrafish. In fact, it's funded by the NIH program for zebrafish tools. But it really is just a general tool for looking at 3D confocal data. And a lot of other biologists and research groups look at confocal data for studying other things than zebrafish. So for example, the Drosophilus community uses confocal microscopy to understand development of Drosophili, and other people are using confocal data for understanding development of other things such as mammals, such as mice. So Gabriel Cardin here at the University of Utah is studying genetic abnormalities in mice and using confocal data to image mice embryos both in vivo and ex vivo, and has found that FluoRender is a valuable tool for her research in the Cardin lab. And so it's nice to see FluoRender go beyond just zebrafish to other biology usages.
The Cardin lab works on how muscle develops, how it regenerates, how you maintain muscle as you age, and what are the causes of muscle loss. We also work on congenital defects in muscle development, such as congenital diaphragmatic hernias. We're using it to image developing limbs and developing diaphragms, which are very complex three-dimensional structures. And so we image them using a confocal microscope, which allows us to optically section through limbs that have been stained with fluorescent antibodies.
When the scan's done running, what I do is I export it as a series of TIFFs, and then we can take these TIFFs, these are all the different Z steps, and import them into FluoRender, and using that program we can make these really beautiful 3D reconstructions that provide a lot of information.
If we were to use conventional software that comes with the microscope, it's actually very difficult to see what's going on in 3 dimensions. So I would say that we would be unable to do any of our work on development of the limbs or development of the diaphragms unless we had FluoRender.